Myself, MS Vidya S. Patil, Assistant Professor, Department of Electrical Engineering, Nasaib Dange College of Engineering and Technology, Staff. Today in this session, we are going to discuss Unit 1 Diode Applications. So, content consists of review of diode, rectifier, half wave rectifier, full wave rectifier. Again, full wave rectifier consists of the center tap transformer rectifier and bridge rectifier. So, in this session, we are going to discuss all these points in detail. So, we are moving towards our next point. Firstly, we will see what is the basic point regarding the diode, and then we will move towards its exact working, its exact operation, and all the details. So firstly, as its name indicate, diode. So di plus ode, it becomes diode. In that, we have divided this diode into two parts that are nothing but first one is a di and second one is a ode. So di means two and O means electrode. So the two electrodes are named as anode and cathode. It becomes a diode, means a device which consists of two electrodes. We called it as a diode. A symbol of diode which consists of two terminals. First one is a anode, which is represented by positive sign, and second one is a cathode, which is represented by negative sign. And one point which we have to keep in mind, that is nothing but diode allow flow of current only in one direction. Okay, so this is a point, and we called it as a symbol of diode. Positive sign indicates anode and negative sign indicates cathode. Second one, also we represent anode in terms of positive semiconductor device, and negative sign is represented in terms of negative semiconductor device. Again, plus sign or anode will be represented in terms of the holes, and negative sign indicates or cathode will be represented in terms of the electrons. So these are the different abbreviations which can be used to represent a diode. Okay, the next point, representation of a semiconductor diode. Already we have seen this is a symbol. This side is anode. After that, a line vertex is there. After line vertex, it indicates the cathode. Again, anode is represented by positive sign and cathode is represented by the negative sign. This is nothing but a schematic symbol of the diode. After that, diode becomes a basic semiconductor device which consists of the p-type material and n-type material. Okay, after that, how physically it look like. So this is the structure or real component appearance of the diode. Here one strip is there. Okay, silver strip is there, which is nothing but strip marks the cathode portion. Okay, here this is nothing but again how that PN junction structure is formed is represented through this symbol. Here a p-type semiconductor material is there and n-type semiconductor material is there. So already we have seen that p-type semiconductor material deals with anode, n-type semiconductor material deals with cathode. Again, in that symbol already we have seen and how it physically look like. So this is the structure. Already I have told that this is nothing but a silver strip which indicates or which marks the cathode terminal, and opposite terminal is nothing but anode terminal. This is nothing but a representation of a semiconductor diode. 6 points regarding diode, then we can easily move towards how PN junction will get formed. So again, in that different symbols are there, electronic symbols are there, or also we called it as a different types of diodes are there. In detail we will see later, but just we can go through these points. Diode already we have seen, positive side indicates anode, negative side indicates the cathode. This is nothing but a simple diode is there. Again, it consists of different types. In that, LED, light emitting diode, in short we called it as a LED. Again, it consists of the two terminals, anode and cathode, and additional part in the symbol is nothing but these arrows. These arrows indicates diode emits the lights. That's why the name light emitting diode. Again, if we move towards our next type, that is nothing but photodiode. Photodiode is nothing but it can absorb the light and that light is converted into equivalent current. Again, a symbol is same. It consists of the two terminals, anode and cathode. Here additional arrows are there, but they are towards the cathode, means it can absorb the light and that light is converted into equivalent current. These are the different electronic symbols of diode, or also we called as these are different types of diode. After that, this is nothing but a physical appearance of the PN junction diode. Means PN junction diode look like this. LED, already we know that it is a light emitting diode. Look like this. It is available in different colors, means red, orange, etc. A third type, that is nothing but a photodiode, and this is nothing but a physical appearance of the photodiode. Already we know that a basic point regarding diode, it consists of the two terminals. The first one is the anode, and after that the second one is the cathode. So this is nothing but first anode, second cathode is there. Like for LED, two terminals are there, anode cathode. Photodiode also consists of the two terminals. Here we have seen that two terminals. Okay, so in short we will see what is exactly PN junction diode, LED diode and photodiode. So a diode is a PN junction with P type on one side and N type on other side. When positive voltage is applied to P type side, it shrinks and overcomes the depletion zone, causing the current to flow from the P type to the N type. That is nothing but a simple diode is there. After that, a second type, light emitting diode. Okay, so light emitting diode are made of two LED semiconductor light source. Okay, gallium arsenide phosphide. It is a PN junction diode which emits the light when activated. Means when we are applying external DC supply to a semiconductor device or a particular diode, then it emits the light. Then that particular diode is known as a light emitting diode. And last one, a photodiode. Photodiode is a semiconductor device that converts light into current. Already I have told that a small amount of current is also produced when no light is present. This is an extra point regarding a photodiode. Okay. After next point, PN junction diode. Okay, if we are going to deal with diode, then it consists of two terminals. First one is anode, second one is a cathode. Again, the different abbreviations that are nothing but if we are going to deal with anode, it is represented by positive sign, or also we call it as a p-type semiconductor material, or also we can represent it with the help of holes. Likewise, if we are going to deal with N-type semiconductor material, or if we are going to deal with second part, that is nothing but cathode, then it consists of the N-type semiconductor material. Also it is represented by electrons. And next part came after that, a PN junction diode. When P-type semiconductor material are connected together with N-type semiconductor material, then one junction is formed, and that junction is known as PN junction diode. Here P-type consists of the large number of holes and N-type consists of the large number of electrons. Okay, and this portion also we called as a P-type semiconductor material. N consists of the N-type semiconductor material. Here P-type material is represented by positive sign and N-type material is represented by negative sign. This is nothing but a basic points regarding PN junction. So once again I am repeating, when P-type semiconductor material are connected together with N-type semiconductor material, then a junction is formed. That junction is known as a PN junction. After that, next part, that is nothing but a diffusion. Two materials are connected together and junction is formed. The next step comes in picture, that is nothing but a diffusion. Okay, so already we know that P-type consists of large number of holes and N-type consists of large number of electrons. So these large number of holes accumulate near the junction in P side and large number of electrons accumulate near the junction in N side. Okay, so after that a process of diffusion will get start. What is exactly diffusion? So transferring of holes towards the electrons and electron towards the holes is known as a diffusion. The next point, depletion region. Already we have seen PN junction, after that diffusion. Once diffusion is started, at that time Electrons can move towards the p-type semiconductor material and holes will get transferred toward the n-type semiconductor material. A next step is formation of depletion region. How that depletion region will get formed? So the point is that when our electrons are moving towards the p-type semiconductor material, at that time here, after the transferring of electron towards the p side, it will leave behind a positive ion near the junction in n-type semiconductor material. Okay. After that, when here transferring of electron towards the p side takes place, at that time a positive ion which will get interacted with that particular positive ion, then repulsion will take place. This is a basic concept, but near the junction there are negative ions are there. So the point is that while transferring the electrons towards the holes, here positive part or positive ion which accepts that particular electron will lose its electrical neutral nature and becomes a negative ion. In this way, a depletion region will get occur. In this depletion region, the ions which are accumulated near the junction in n side are positive and in p side are negative. So this is nothing but a shaded region which indicates the depletion region. The depletion region consists of the immobile ions, immobile positive and negative ions. After that, a barrier potential. Already we have seen regarding the depletion region or how a depletion region will get created. After that, a next step is a barrier potential. Barrier potential is also known as a junction potential. How will it get created? So again, it consists of the p-type semiconductor material, n-type semiconductor material. Near the junction, here a positive ions will get accumulate, and in p-type semiconductor material negative ions will get accumulate, and these ions are nothing but the immobile ions which are accumulate near the junction. So due to these immobile ions near the junction, or we will say that due to the immobile positive and negative ions near the junction, an electric field is created. This is nothing but an electric field. Electric field is created, and that electric field is known as a barrier potential or junction potential. So different material having different values for this potential barrier or junction potential. That is nothing but here I have tabulated material and its value. So for silicon, barrier potential or junction potential is 0.6 volts, and for germanium it is a 0.2 volts. One point also keep in mind, barrier potential or junction potential is also known as a cut-in voltage. After that, we are moving towards our next point, concept of biasing. Concept of biasing, whatever the operation we have seen in the last slides, that is or that deals with a unbiased operation, then we are now moving towards the concept of biasing. What is biasing? So biasing is a process of applying external DC supply to a semiconductor device. Once again I am repeating, biasing is a process of applying external DC supply to a semiconductor device. Okay. So a voltage applied to a semiconductor diode is referred to as a biased voltage. Depending on the biasing, there are two types of bias voltages are there. First one is a forward biased and second one is a reverse biased. So first type, that is nothing but a forward biasing. So what is actual forward biasing? How the operation will take place? We will discuss here. So this is the best way of representing a forward biasing. P-type semiconductor consists of large number of holes. N-type semiconductor consists of large number of electrons. This is a basic concept, and here we are applying external DC supply because we are going to bias a PN junction in forward bias. So As per that, we will see the terminals. In forward biasing, external positive supply is connected to a p-type semiconductor material, and external negative supply is connected to the n-type semiconductor material. Already we know that the concept how p-n junction will get formed when p-type semiconductor material are connected together with n-type semiconductor material. Then a junction is formed, and that junction is known as p-n junction diode. After applying external DC supply in this way is nothing but external positive terminal is connected to p-type and external negative terminal is connected to n-type. This type of biasing is known as forward biasing. Again, positive terminal of battery connected with p-type, negative terminal of battery connected with n-type. After the connection, maximum current will start to flow from anode towards the cathode. Means here flowing of current takes place. IF indicates the forward current because our diode operates in forward bias. Here the width of depletion region, this black strip indicates the depletion region. In the forward bias, depletion region is small as compared to the reverse bias. We will see reverse biasing, a basic concept only we are going to see. Here also a p-type semiconductor material is there which consists of large number of holes, and n-type semiconductor having large number of electrons. After that, here this is nothing but one kind of strip which indicates the depletion region. Here width of depletion region is large in the reverse bias. Okay, we will see the basic concept regarding reverse biasing. Negative terminal of battery is connected to p-type semiconductor material, and positive terminal of battery is connected to n-type semiconductor material, and this process is known as reverse biasing of diode. Here extremely small current flow through the diode during reverse biasing. Here a depletion region is large as compared to the reverse biasing. Okay, where this kind of biasing takes place, so Zener and avalanche breakdown occurs in it, in this type of reverse biasing. Here we will see in detail point. Already we have discussed the point regarding width of depletion region is small in forward bias and width of depletion region is large in reverse bias. But how it actually takes place, we will see here. So width of depletion layer or region in forward bias. This is nothing but in general circuitry, and here we will see this is nothing but first diagram indicates the unbiased diode. Unbiased means there is no any kind of external DC supply is added in this particular system. But here we will see this is nothing but an external DC supply we are added in the system. Again, regarding forward bias, external positive terminal is connected to p-type material and external negative terminal is connected to n-type material. Near the junction in p region electrons are there, and near the junction in n-type region positive ions or holes are there. Okay, so when p-n junction is forward biased, the width of depletion region is reduced and barrier potential is also reduced. If we consider positive ion and positive ion, they are repel, and if we consider positive and negative ion, then they are attracted towards the each other. In this way, if here positive side is connected to p-type material, so it consists of the large number of holes, and here negative ions are there, so positive negative becomes neutral. Okay, so in this way width of depletion region will get reduced. Same concept takes place here. Negative ions are there, and here near the junction positive ions are there, so negative positive becomes neutral, and one point came where complete depletion region will get damaged, or complete depletion region will get breakdown, and a smooth current will get flow from P towards the N side. This is nothing but a forward biasing. That's why width of depletion region is small as compared to reverse bias. We will see in detail reverse bias process. So width of depletion layer in the reverse bias. Here also we will see here these are nothing but the immobile ions near the junction. Here first diagram indicates the unbiased operation and second diagram indicates the biased operation. Here this is nothing but this indicates here a depletion region is small before the biasing. After biasing, depletion region will get increased in reverse bias. How? Positive terminal of battery is connected to n-type material and negative terminal of battery is connected to p-type material. How the operation will take place? So here positive ions are there, and here negative ions are there. So positive, negative attracted towards each other. That's why in this way this area will get enlarged. Same process will take place. Here negative ions are there and here positive ions, so they are attracted towards each other. Therefore this region also will get widened. In this way a depletion region will get large in the reverse bias. So this is a key point. When a PN junction is reverse bias, depletion region is widened and the barrier potential is also increased. Then next point, applications of diode. There are n number of applications of diodes which consist of the rectifier is there, then clipper is there, clamper is there, voltage doubler is there, signal modulator is there, signal demodulator is there, signal mixture is there, and also diode is used as a switch. One by one we will see, but today in this session we are going to deal with our important application, that is nothing but rectifier, which is mostly used. That's why we are firstly dealing with our rectifier application. So design of rectifier circuits. Here a rectifier, firstly before going in detail its types, we will see what is the exactly rectifier. Okay, so rectifier, it is electronic device which converts AC into DC or AC supply into DC supply, or also we call it as a AC voltage or current into DC voltage or current. Okay, it consists of the mainly two types. First one is a half wave rectifier and second one is a full wave rectifier. Full wave rectifier is again converted into two types, that are nothing but center tap transformer rectifier and bridge rectifier. Different applications of rectifier are nothing but DC welder system, DC motor drive, battery charger, DC power supply, HVDC system. In these particular systems we can apply the rectifier. Okay, so these are the flow chart. Okay, representation of types of rectifier in detail, which are exactly operation of half wave rectifier, full wave rectifier, center tap full wave rectifier and full bridge rectifier. We will see later on. Thank you.